Hello guys, today we're going to solve a sample problem in chapter 2 of thermodynamics and heat transfer, the properties of pure substance. The sample problem is, a 5 cubic feet rigid tank contains 5-pound mass of water at 20 pounds per square inch absolute. Determine the temperature, the total enthalpy, and the mass given phase of water. The given values are volume is equals to 5 cubic feet, the mass which is 5-pound mass, and the pressure which is 20 pound per square inch absolute. So before we proceed, we were going to solve for our specific volume, which is specific volume equals to the total volume over mass. Plug in the values, we have 5 cubic feet over 5-pound mass equals to 1.0 cubic feet per pound mass. At 20 pounds per square inch absolute, in our property table, we have saturated liquid or V sub F equals to 0.01683 cubic feet per pound mass, and saturated vapor is equals to 20.093 cubic feet per pound from our table A-5. So, the tank contains saturated liquid vapor mixture and the temperature must be the saturation temperature at a specified pressure in which it is equals to 227.92 degree Fahrenheit from our property table in table A-5E. Next, we need to determine the equality of water and its total enthalpy. So we were going to use the formula quality of X is equals to the specific volume minus the volume of our saturated liquid over the volume of our saturated liquid and vapor. Plug in the values, we have 1.0 minus 0.01683 over 20.093 minus 0.01683 is equals to 0.04897. This is the value of our quality X. Next, for our specific enthalpy, from our property table at table A-5E, we determine the value of our enthalpy at saturated liquid, which is 196.27 British thermal unit per pound mass, and the enthalpy at evaporated phase is equals to 959.93 British thermal unit per pound mass. In finding the specific enthalpy, we use the formula specific enthalpy equals to enthalpy at saturated liquid added to the product of our quality X and the enthalpy at evaporated phase. So plug in the values, we have 196.27 British thermal unit per pound mass plus 0.04897 multiplied to 959.93 British thermal unit per pound mass, we have 243.28 British thermal unit per pound mass as our specific enthalpy. So in total, our total enthalpy, we use the formula total enthalpy equals mass times specific enthalpy. We have 5-pound mass multiplied to 243.28 British thermal unit per pound mass. Then crush out the same units, we have 1,216.4 British thermal unit. Lastly, we were going to determine for the mass of each phase, but before that, we were going to solve first the mass at saturated vapor phase. We use the formula mass at saturated vapor phase equals to quantity X times the mass total. Plug in the values. We have 0.04897 multiplied to 5 pound mass is equals to 0.245 pound mass. So in finding the mass of each phase, we use the formula mass total equals to mass at saturated liquid added to mass at saturated vapor. Since the mass of saturated liquid is unknown, so we were going to subtract the mass of the saturated vapor to the total mass, which is 5 pound minus 0.245 pound mass is equals to 4.755 pound mass. So 4.755 pound mass is our mass at saturated liquid phase. So that's it for today, guys. I hope you've learned something and thank you for watching.